Okay, today we're going to talk about right triangles. And so far with right triangles, you guys already know Pythagorean theorem. And you know if you have two sides of a right triangle, you can use a squared plus b squared equals c squared to find the other side. Well, if you have one side of the right triangle, so currently you don't know how to find the other two sides. Well, what we're going to use today is going to teach you how to do that. So on your orange piece of paper, you should have folded it hamburger style and you should have cut 3 flaps like this. And I want you to write S-O-H on this first flap. On the second one, you're going to write C-A-H. And on the third flap, you're going to write T-O-A. Okay, this is pronounced SohCahToa. SohCahToa. And SohCahToa is an acronym like we did with Unit 5 with the centers of triangles, or we did like crunchy peanut butter is always better. This is the same kind of thing. These letters all stand for something. The S, the C, and the T stand for 3 different types of functions. Just like in algebra, you learned about linear functions and exponential functions. Now we have what's called the sine function, cosine function, and tangent function. These are 3 trig functions, and you'll do the algebra parts of them and their graphs and solve problems with them and all that when you guys get to Algebra 2 and pre-calculus. But right now, the 3 trig functions, sine, cosine, and tangent, are used to help us solve right triangles. And on your calculator, see these 3 buttons right here? Sine, cosine, tangent. Those are the 3 buttons we're going to use. So we'll talk about how to use your calculator later. Okay, open up your first flap, and we're going to write out what the letters SohCahToa actually stand for. So over here on the inside of this flap, I want you to write S-O-H vertically. The S stands for sine, and it's spelled S-I-N-E. The O stands for opposite, and the H stands for hypotenuse. Okay, over here on this side, I want you to draw a right triangle. Okay, so these 3 trig functions, sine, cosine, tangent, only work for right triangles. So you've got your right triangle, and I'm going to teach you a new Greek symbol. You know how if I put pi, that's a Greek symbol, and everybody knows that that means 3.14? Well, there's a Greek symbol that looks, I draw it like this. Sometimes you'll see it like this, and it's pronounced theta. And theta is what we use when we're trying to find a missing angle. So when we don't know the measure of an angle, instead of putting x or y, we'll just draw this little symbol, which is called theta, and theta represents the missing angle. Okay? So in your picture down here at the bottom, I want you to put theta to represent that angle right there. Excuse me. All right. Looking at where theta is, remember how we just said that sine is opposite over hypotenuse? You're going to base opposite based on where theta is. So if this is theta, the side that is opposite theta is this side over here. So we're going to write opposite on that side. The hypotenuse, of course, is the side that's across from the right angle. So this is your hypotenuse. So if you had a picture of a right triangle, and you had your angle right here, and you had like an X there and a 12 there. If you had the side that was opposite theta and you had the hypotenuse, or even if this was your 12 and this side was your X, you would use the sine function. So if your picture looks like this, you're going to use the sine function to solve it. And to solve it, your equation is sine of theta, and we abbreviate that just S-I-N, but you don't pronounce it sin. You always call this sine. So sine of theta equals opposite over hypotenuse. See how we learned it as sine is opposite hypotenuse? So the opposite goes first. So sine is opposite over hypotenuse. So, okay, so if you remember so, you can remember sine is opposite over hypotenuse. So this is what your picture looks like when you are trying to use the sine function. Okay, and I'm going to show you an example of how you're going to use this in the next video. All right, the next one is cosine. So we're going to write our letters, C-A-H for ca, cosine. The A stands for adjacent, and the H stands for hypotenuse. All right, cosine is adjacent and hypotenuse. We're going to draw the same right triangle. You're going to put your theta down here in the same angle from before. Now this time, we want the side that is adjacent. Adjacent, if you remember from Unit 2, means next to. So when I'm looking at theta, this bottom side is next to theta, and this side right here is next to theta. Well, this side is my hypotenuse because it's across in the right angle. So this will always be hypotenuse. You will never call this adjacent. But this side down here is next to theta, and it's not the hypotenuse. So this is our adjacent side right here. So if your picture looks like this, if you have this angle and you know the adjacent side and the hypotenuse, you're not going to use sine, because sine is for when your picture, when you know those two sides. But if you know these two sides, you're going to use cosine. And so your equation is going to be cosine of theta, what was it, bad theta, equals adjacent over hypotenuse. And it's the same thing as the A goes over the H because of the word ca. Cosine is adjacent over hypotenuse, so your adjacent goes on top. Okay? And then our last trig function is tangent. So we're going to write out the words T-O-A, toa. So this is SohCahToa. T is for tangent. And tangent, the O is for opposite. And the A is for adjacent. And then you draw your triangle. Okay. And since tangent is opposite and adjacent, when you're looking at your theta, the side that's opposite theta over here, and this is your side right here that is adjacent. So if your picture looks like this, if you know those two sides, then you'll use the tangent function to solve for your sides, okay? So your equation is tangent theta equals opposite over adjacent. And the opposite goes first because you've got opposite over adjacent in TOA. Okay? So these are your trig functions. So now what I want you to do is in your ISN on page 67, you're going to write out some examples. This goes on page 68. So tape this on 68, and on page 67, I want you to write example 1. We're going to do 5 examples on this page. Okay, for example 1, we're going to draw a triangle. And put your theta up here in the top. Call this side 12, that side 15, and this side 9. Okay, we're not actually going to solve anything in this video. We're just going to practice understanding what sine, cosine, and tangent are. So if I asked you to find sine of theta, if this is your theta here, sine is so, and so is O and H. So you're looking for the side that is opposite theta. So when I look at theta, this side is opposite, and then my hypotenuse is the side that's across in the right angles. There's my H. So if I'm doing sine of theta, it's going to be 9 opposite over 15, your hypotenuse. So sine is opposite over hypotenuse. So this is what your equation would look like. If I'm doing cosine of theta, cosine is ca. Ca is A and H, adjacent and hypotenuse. If this is my theta, this is the side that's next to it, so that's my A, and then my hypotenuse is 15. So cosine of theta is 12 over 15, because that's your adjacent over hypotenuse. you're doing tangent of theta. Tangent is TOA. TOA is opposite and adjacent, O and A. So when I look at my theta here, my opposite is 9, and my adjacent is 12. So tangent of theta is 9 over 12. So you can see that each of these functions produce different fractions. We'll actually convert these to decimals when we're solving the equations. But I want you to just to understand that the difference is in the three functions. Okay? All right. Next, you're going to watch video 2 to learn how to actually use SohCahToa to find a missing side.